In previous class, we discussed about what happened when we hit a iron rod. Okay. In this class, we are going to discuss about the Bohr model of hydrogen atom and its limitation. Okay. Let us examine the spectrum of hydrogen atom. What does the line spectrum tell us about the structure of atoms? Niels Bohr proposed that electrons in an atom occupy stationary orbits, states of fixed energy at different distance from the nucleus. Okay, when an electron jumps from lower energy state to higher energy state, it absorbs energy. When it is jumped from lower energy state is called as ground state, and higher energy state is called as excited state. When the electron jumps from lower energy state to higher energy state, it absorbs energy, and it emits energy when it jumps from higher energy state to lower energy state. Okay, so Niels Bohr, he said that electrons in an atom occupy stationary orbits or states of fixed energy at different distance from the nucleus. Okay, so means he said that around the nucleus in certain places we can observe the electrons. Okay, means around the nucleus electrons are revolving around the nucleus in circular path. These are called as energy levels or shells or orbits, he said. Okay, so these energy levels or shells are showed by n is equals to 1, 2, 3, 4 or k, l, m, n. Okay, when an electron jumps from lower energy state to higher energy state, it absorbs energy. Okay, so this lower energy state is called as ground state, higher energy state is called as excited state. So when the electron jumps from ground state to excited state, it absorbs energy. And when the electron jump, when the electron jump occurs from higher energy state to lower energy state, it emits energy. Okay, it emits energy. The energies of an electron in atom can have only certain values, E1, E2, E3, etc. Okay, so the states corresponding to these energies are called as stationary states, and the possible values of the energy is called as energy level. So this Niels Bohr proposed that the electrons in an atom occupy stationary orbits or states of fixed energy at different distance from the nucleus. Means electrons are revolving around the nucleus in circular path. These are called as energy levels or shells. Okay, so when the electron jump from lower energy state to means ground state to higher energy state, it absorbs energy, and when the jump occurs from higher energy state to lower energy state, it emits energy. The energies of an electron in an atom can have only certain values, E1, E2 and E3, means that the energy is quantized. So the electrons in the atom have certain energy levels that are showed by E1, E2 and E3. Okay, so the states corresponding to these energies are called as stationary states, and the possible values of the energy are called as energy levels. Okay, the lowest energy state of the electron is known as ground state. So the lower energy state of the electron is known as ground state. What happens when an electron gain energy? When an electron gain energy, the electron moves to higher energy level, means that is going into higher energy level, that only called as excited state. Does the electron retain the energy forever? So if the electron gain energy, then that is going to higher energy level, so that will be gain that is gaining energy, that retain that energy like that only? No, the electron loses energy and come back to its ground state. Okay, so the energy emitted by the electron is seen in the form of electromagnetic energy, and when the wavelength in the visible region is the visible as a emission line. So here the lowest energy state of an electron is known as ground state. So what happens when an electron gain energy? When the electron gain energy, it is moving to excited state. So that electron is gaining energy and moving to higher state, no, moving to higher energy state, no, means moving to excited state, no, that retain its energy like that only? No, the electron loses the energy and it is coming back to its ground state, and the energy emitted by the electron seen in the form of electromagnetic energy, and when the wavelength in the visible region, it is as visible as a emission line. Okay, so that released energy we can see in the form of emission line. The electron absorbing energy moving to higher state, no, again it is staying in the higher state like that only? No, that is losing the energy and it is coming back to ground state and releasing energy, means that is here the electron absorbing energy and moving from ground state to higher state. So that will be present in the higher state like that only? No, it will not stay in the higher energy level like that only. Again it will come back to ground state by emitting the light, okay, by releasing the light. It is again it will coming back from higher energy to lower energy level. Okay, that visible light we can see, okay, that is releasing one light, means that is like that is appears like a different colored light, means during the fireworks Diwali festival we will see different types of colors, no, like that we can see the different colored light. Okay, and that color have different wavelength. This Bohr atomic model explains the line spectra observed in the space in the case of hydrogen atom. Okay, it is successful model as far as line spectra of hydrogen atom is concerned. Means this Bohr atomic model explaining about the line spectra that is observed by hydrogen. Okay, Bohr model explains all the line spectra observed in the case of hydrogen atom. It is a successful model as far as the line spectra of a hydrogen atom is observed. Thus, what is the meaning of line spectra? Means each element emits its own characteristics of color corresponding to certain discrete wavelength of light. This is called as line spectra. Line spectra is nothing but each element emits its own characteristics of color, okay, corresponding to discrete its wavelength, that is called as line spectra. So this Bohr model explaining about the hydrogen spectra. Okay, and but line spectrum of hydrogen atom, but the line spectrum of this hydrogen atom, when it is observed through the high resolution spectroscope, it appears as groups of finer lines. Okay, so when the line spectrum of hydrogen, when it is observed with high powered spectroscope, again it is splitting into small lines. Again that splitting into small lines. So about that this Bohr model does not explain. So but the line spectrum of hydrogen, when it is observed through the high resolution spectroscope, it appears to be group of finer lines. Means hydrogen spectrum, when it is in the line spectrum of hydrogen, when it is observed with the high resolution spectroscope, it is splitting into smaller lines. About that this Bohr model is not explained, and Bohr model is failed to account for the splitting of line spectra. Means in each line splitting into so many lines. About that this Bohr model is not explained. Okay, so to explain about this Sommerfeld one model proposed. Okay, that model is called as Bohr-Sommerfeld model of atom. In an attempt to account of the structure of splitting of line spectra is known as fine spectrum, Sommerfeld modified the Bohr atomic model by adding the elliptical addend. While retaining the first of the Bohr circular orbit, as such, he added one elliptical orbit. Okay, he added one elliptical orbit to Bohr second orbit, and he added two elliptical orbit to Bohr third orbit. Such the nucleus and the atom of in one principal Fourier of this elliptical orbit. He was guided by the fact that the general periodic motion under the influence of a central force lead to elliptical orbits for situated Fourier. Bohr-Sommerfeld model thought successful accounting for the fine line spectrum of hydrogen atomic spectra does not provide a satisfactory picture of the structure of the atom in general. This model is failure to account the atomic spectra of atom more than one electron. Why is the electron in atom restricted in a certain fixed distances? One more topic, Sommerfeld model, Bohr-Sommerfeld model. So Bohr, he invented the orbits, and Sommerfeld, he invented the suborbit. Okay, so Bohr, he invented the atomic model of hydrogen. Bohr, he explained about the atomic model. Bohr invented the atomic model, and Bohr, he observed the hydrogen spectrum. Bohr observed hydrogen spectrum also. From that he observed line spectrum also. Bohr invented orbits and Sommerfeld invented suborbits. Okay, so Bohr explained the atomic model, and he observed the hydrogen spectrum, and from that he observed the line spectrum also. Okay, so what happened if the light coming from the H2 hydrogen atom sent onto the prism? Okay, so we send the light coming from the hydrogen atom onto the prism, then this is disperse. Okay, and this is dispersal. Okay, so this is Bohr observation. So this is it is on our theory. So all the members read this only. So in the all members, Sommerfeld also one of the person, he is also observed that, but he thought that I will do this with my own, he said like that. Okay, so the same experiment again done and done by the Sommerfeld, and he said the correct matter. Okay, what is that means? He took prism and he took hydrogen lamp. He sent the light coming from the prism onto the sent the light coming from the hydrogen lamp onto the prism. Then what happened? It is splitting into different color. Okay, when we send the light onto the prism, we can observe that is splitting into different colors. Okay, different lines. Okay, so what are that? N is equals to 1. Okay, when we send light onto the prism, it is splitting into different colors. So sorry, when he sent the light coming from the hydrogen lamp onto the prism, it is splitting into so many lines. Okay, so these lines Sommerfeld observed with high resolved spectroscope. Okay, so he used a microscope with high resolved. Okay, he used the high resolved spectroscope. Okay, high resolved microscope. Okay, so means the light coming from the hydrogen lamp he sent onto the prism, then that is splitting into different lines. So these lines Sommerfeld observed with high resolved microscope. Then first line is there, no, in that he does not any other lines. Okay, and that is n is equals to 1 shell. Okay, and second line n is equals to 2 is there, no, in that he observed two closely packed lines, and third line he observed 3 closely packed lines. In fourth line he observed 4 closely packed lines. Okay, by this he said that in atoms in atoms not only orbits, suborbitals are there, he thought like that. Okay, so so by this he said that in orbits again suborbits are there, he said like this. Okay, in first orbit only one suborbit there, that is S, means from the hydrogen lamp light is coming, no, he send that pass that light onto the prism, then that is splitting into different lines. No, in first line he does not observe any lines, means that is n is equals to 1 shell, in that only one subshell is there, that is 1s. And second line is there, no, that second line is splitting into 2 closely packed lines. He said that oh, in that 2 subshells are there, that are 2s 2p. Third line he observed that 3 closely packed lines. He said that in the 3 subshells are there, that are 3s 3p 3d, he said. In fourth line he observed 4 closely packed lines. He said that in that 4 subshells are there, what are that? 4s 4p 4d 4f, like that he said. So Sommerfeld proposed the subshells. Okay, shells are proposed by Bohr, subshells are proposed by Sommerfeld. Okay, he kept the Bohr atomic model like that only. Okay, Bohr circular path he kept like that only, but he added one elliptical orbit. Okay, in n is equals to 1 circular path like that only there, that is L is equals to 0. N is equal to 2, in that he added one elliptical orbit. N is equal to 3, he added in the 2 elliptical orbits. N is equals to 4, he added 3 elliptical orbit. Okay, here n is equals to 1, L is equal to 0 means n is equals to 1, only one subshell, that is S. N is equals to 2 means one circular path is there, one elliptical orbit is there, means L is equals to 0 means that is S. L is equals to 1 means P. Okay, N is equals to 3 means 3 subshells. What are that? 3S, 3P, 3D. What are its L value? S L value 0 and P L value 1 and D L value 2. Okay, N is equals to 4. In that 4 subshells are there. Okay, what are that? 4S, 4P, 4D, 4F. 4S L value 0 and 4P L value 1, 4D L value 2. Okay, and 4F L value 3. Like that he said, means in shells subshells are there that are proposed by Sommerfeld. And this model is failed to account for the atomic spectra of atoms of more than one electron. Bohr-Sommerfeld model thought is successful in accounting for the fine line spectrum of hydrogen atomic spectra, does not provide a satisfactory picture of the structure of atom in general. Okay, it's this Bohr-Sommerfeld model explaining about the atomic spectrum of a hydrogen, but it does not giving satisfactory information about the atomic structure. Okay, and it does not explaining, this model is failed to explain about the atomic spectra of atoms of more than one electron. Okay, so why is the electrons in an atom restricted to revolve around the nucleus in a certain fixed distance? Why is the certain an atom restricted to revolve around the nucleus in a certain fixed distance? Now we discuss about quantum mechanical model of atom. Do the electrons follow defined path around the nucleus? So electrons are revolving around the nucleus in circular paths. If the electrons are revolving around the nucleus in defined paths or orbit, the exact position of the electron at various times will be known. If the electrons are revolving around the nucleus in definite path, then we can know easily the exact position of the electron various times. For that, we have to answer to these two questions. What is the velocity of electron? Is it possible to find the exact position of an electron? No, it is not possible. Why? Because electrons are invisible to naked eye. Then how do you find the position of a velocity of an electron? To find the articles during the dark night, we take the help of torchlight. Similarly, we can take the help of suitable light to find the position and velocity of an electron. So as the electrons are very small, light of very short wavelength is required for this. So the short wavelength of light interact with the electron and disturb the motion of the electrons. So simultaneously the position and velocity of electron cannot be measured accurately. So from the above discussion, it is clear that electrons do not follow the definite path in the atom. Okay, so around the nucleus, electrons are not follow the definite path. Okay, so why? Because here if it is follow the same path various times, we have to know answer to these two questions. What is the velocity of electron? It is possible to find the exact position of an electron? No, it is not possible. Why? Because electrons are very small. And then how do you find the position of a velocity of an electron? Okay, so here to find the articles during the dark night, we will take the help of torchlight. We can take the suitable light to find the position and velocity of electron. As a result, electrons are very small. To find the exact position of a electron, we need to take the short wavelength of light. When we use the short wavelength of a light to identify the position of a electron, it disturbs the motion of a electron. Hence, the position and velocity of electron cannot be measured accurately. So from the above discussion, we can say that the electrons do not follow the definite path around the atom. Okay. So, do atoms have definite boundary as suggested by Bohr model? If the electrons are not distributed in orbits around the nucleus, this means atoms does not have definite boundary. Okay. So, around the nucleus in circular path, the orbitals in the circular path in the orbitals, electrons are not there. Electrons does not follow the definite path around the nucleus. It does not have definite boundary. So in atom, where is the electrons, we cannot say easily. Okay, so do atoms have a definite boundary suggested by the Bohr model? If the electrons are not distributed in orbits around the nucleus, this means that an atom does not have a definite boundary. As a result, it is not possible to pinpoint the electron in an atom. Under this circumference, in order to understand the properties of electron in an atom, quantum mechanic model of an atom was developed by Erwin Schrödinger. Okay, so around the nucleus, electrons does not follow the same circular path. Okay, so to overcome this, a quantum mechanic model was proposed by Erwin Schrödinger to understand about the properties of a electron in an atom. So according to this Erwin Schrödinger model of an atom, instead orbits of Bohr model, according to this Erwin Schrödinger model of an atom, instead the orbits of Bohr model, the electrons are thought to exist in particular region of a space around the nucleus in a given instant of time. Means instead of this Bohr model, around the nucleus in particular places the electrons will be present. Okay, the electrons are thought to be exist in particular region of a space around the nucleus at a given instant of time. Okay, so what do we call that region of space where the electrons might to be given at time? The region of space around the nucleus where the probability of finding of electron maximum is called as orbital. Okay, so around the nucleus in certain places the electrons will be present. That places means the region are according to model of an atom, instead of orbits of Bohr model, the electrons start to be exist in a particular region of space around the nucleus at a given instant of time. So the region of space around the nucleus where the probability of finding of an electron maximum is called as orbital. So in a given space around the nucleus, in certain orbitals can exist. Each orbitals of a stable energy state for the electron is described by particular quantum number. Okay, in the space around the nucleus some electrons will be there, no, that are existed by particular quantum numbers. We will learn about the quantum numbers in next class.